All right, welcome back to geometry. This is classwork 155 and 156. Here's the homework. There is a little problem that we would be doing in class, but you're going to have to find a tissue box and a piece of string or a pipe cleaner at home to do this problem. You could actually even use your imagination, but you're going to have to bring a tissue box back into school with you when we return. But go ahead and write this down, and here we go for today. This is on the board. We're continuing with the Pythagorean theorem. This is number 12 from your homework on the board, from your homework last night. I will go over, but let's go ahead and talk about number 12. Number 12, you are given this shape right here. You're given what looks like it's a square, but you need to know the properties of a square. And the properties of a square are all four sides are congruent, and it has 90-degree angles. Okay? So I've got four congruent sides, and I've got what looks to be here an angle bisector. And it is an angle bisector because you're given, everything on the board in purple is what you're given. You're given that this angle right here is 45, and this angle right here is 45. So from the properties that you know, you've got a 90-degree angle here. All four of your sides are congruent, therefore you know that all four angles are congruent. The hypotenuse then of this triangle, this length of this angle bisector right here is 6 square root of 2. And this is the information you know just from looking at the diagram in your book, which might have been a little confusing, but I wasn't nearly beyond you. All right, so we know we have a square. We know we have two isosceles triangles, and I'm going to go ahead and work with this one on top. The one on bottom is absolutely congruent to the one on top. And then I know my hypotenuse is 6 square root of 2. So I'm going to go ahead and plug into my Pythagorean theorem right here. I have a squared plus b squared is equal to c squared. All right? I have my leg of my right triangle, my leg of my right triangle. So I have x squared plus x squared is equal to 6 radical 2 square root of times square root of 2 quantity squared. Now this goes back to Algebra 1 last year where we did these exponent rules. I can't just square this and drop the radical. I have to square each term inside of the term, each small term inside of the parentheses. So I distribute this 2 to both terms in here, and so I combine my like terms here and have 2x squared is equal to 6 squared times radical 2 squared, square root of 2 squared. 2x squared is equal to 6 squared is 36, radical 2 squared is just 2. So then I just solve like a normal equation and see if I get down to something that would make sense. So I have 2x squared is equal to 72. Divide both sides by 2, I get x squared is equal to 36. I take the square root of both sides and x equals 6. Absolutely makes sense. Are we okay there? All right, I'm going to run through the answers to the rest of the problems from your homework so you can evaluate your progress and how you've done. Number 1 is 5. Number 2 is 13. Number 3 is 8. Number 4 is 2 radical 10. Don't give me some big astronomical decimal. That is horribly ugly. And definitely don't give me the square root of 40. I want it reduced down to simplest radical form or else it will be wrong. It's kind of like reducing a fraction. You wouldn't give me a fraction that was 10 over 20. I want that reduced down to 1/2. Same with radicals. Number 4 is 10 radical 3. Number 6 is 4 radical 5. Number 7 is 8. Number 8 is 6. Number 9 is 25. Number 10 is 9. Number 11 is 8 radical 2. And number 12 is 6. We just did that one on the board. Did we do 13? No? What was our next one?
14.
14. 14 should have a width of 1. 16 sorry, evens. 6 radical 2. You probably just needed to draw those out. You have the descriptors, just draw them out. Number 17 through 21, right? Mm-hmm. All right, 17, you should have 68. Find the perimeter. You had to use the Pythagorean theorem to find one of the sides, and then add up all 4 sides. A rhombus, you have to know the properties of a rhombus. Think back to when we identified properties of all quadrilaterals. The properties of a rhombus, all 4 sides are congruent. Where are we now? Number 18, same thing. Number 18, the answer is 16 centimeters. Number 19, you should have 3. You can tell by that the altitude is a bisector because you have an isosceles triangle. So an altitude from the 90-degree angle to the hypotenuse is going to bisect that angle. So it's going to bisect and be the median of the hypotenuse also. Number 20, same thing. Number 19, your answer is 3. Number 20, your answer is 8. And number 21, your answer is 3 radical 5. I hope that helps. All right, my plan for today is to just do a few practice problems and then set you free. And again, I mentioned that you're going to need to find an empty tissue box, which hopefully around your house is not going to be difficult because it is tissue season. So let's go ahead, open up your books to page 293. And we're going to look at 23, 25, and 27. All right, let me go ahead and redraw number 23 for you here. We have an isosceles trapezoid that we're dealing with. Sorry, your objective today, so sorry I didn't write that on the board at the beginning, is to use the Pythagorean theorem to solve for missing pieces of shapes. How about that? All right, so we have number 23. I'm on page 293. I have this isosceles trapezoid, which is nice that they're giving us nice shapes to work with. I have the altitude on both sides, and they've given me that the base is 21. This is 11. Oh, interesting. This is 13. This is 13. This is X, and this is X. All right. So in my purple on the board is what you are given in from the problem. So let's go ahead and deduce everything we know from what's been given. Sorry, and they give us that these are right angles. So they give that this is a perpendicular, this altitude. Since it's an altitude, it's perpendicular to the base of this trapezoid. So let's go ahead. We know that this is a square right here. So this is 11 right here. Does that make sense? And so we know that we have 10 left over. So we can assume that this is going to be 5 and this is going to be 5 because this is an isosceles trapezoid. So if you're not writing this down, pick up your pencil and do it right now. Probably for the people in the video too, as with my live subjects in class. Seriously, boys. All right, so now we can go ahead and solve for x. So go ahead, we're using Pythagorean theorem. And by the way, you guys aren't here, so I'm probably paraphrasing because I'm trying to make these videos not too long because they take forever to post. Every time, listen, every time you are going to use Pythagorean theorem, and this is me being the stickler that I am, you have to rewrite the formula before you substitute into it. Don't roll your eyes, don't throw your head back. Okay? I want to know the quality of work that you are doing, and you need to rewrite the Pythagorean theorem. It's only like It's going to take you half a second, maybe 2 seconds. All right, so I have A. I'm solving for x. So here is my right triangle. So I'm going to let A be 5. I don't know what B is because this is a leg. I know it's a leg because it's not my hypotenuse, because my hypotenuse is opposite my right angle. It's across from it. My hypotenuse is never, never, never adjacent to my right angle. Don't let that confuse you. So then I have equal to 13 squared. So I have 25 plus b squared is equal to 169. I'm going to subtract 25, subtract 25. This is going to give us a nice number. 144 is equal to b squared. I'm going to take the square root of both sides and have b is equal to 12. So what I have here is a side length that's equal to 12. So x is equal to 12. In classes to come, you're going to like this 5, 12, 13. We're going to have what's called a Pythagorean triple. So yesterday we did a 3, 4, 5. Today we have a 5, 12, 13. Now you're going to start to recognize these and go, oh, I like it when I have a 5 and a 13 because I'm going to know that my other leg is 12. Okay, we like working with perfect squares because then you don't have to simplify your radical. And you like it when you don't have to simplify a radical. All right, that's number 23. Let's see, do I have room on that camera? Let's go ahead and erase. Hopefully you have it done. If not, go ahead and pause the camera. Let's work on 25. So what you're doing is basically applying the properties of the shapes that we've already learned about in class and applying them to these problems here. All right. And I love this part of geometry. This is my favorite part of geometry. Oh, this is why I love it. And you're not here to roll your eyes and sigh at me, so I'm going to tell you how much I love geometry all the time while I get the chance. All right, we've been given this. This is a trapezoid. It is not an isosceles trapezoid. Don't worry, that's not the bell for your class. Okay? It's not an isosceles trapezoid, but it is a trapezoid because I have two right angles here, which indicates that these two sides are parallel. All right, and it says solve for x. But I don't have a line. How am I going to solve for x? I don't have a triangle. You do. You're going to have to draw it in. Okay? I have this triangle right here. I can drop my altitude of the trapezoid, and I'm going to have this as 8. The altitude is how tall it is, so I can just add another line in there, so that altitude is 8. Now that altitude is going to intersect here at a 90-degree angle, so here's my right triangle right here, and this length between my side and my altitude is 5, so 11 minus 5 is going to leave me 6 over here. And this is going to give you a nice number 2. This is going to be a multiple of this Pythagorean triple that I just talked about. All right, so let's go ahead and solve for x now that I have my right triangle. So I have my leg is, I have a squared plus b squared is equal to c squared. 6 squared plus 8 squared is equal to c squared. I have 36 plus 64 is equal to c squared. These should be kind of, these squares and these square roots, you should have hopefully committed them to memory by now. If not, they should be becoming more familiar as we move on. So then I have 100. 100 is a great number to have c squared equal to because I take the square root of both sides and c is equal to 10. So that's nice. Do we have to do anything else here? No, but with this information, you could find the perimeter of this shape. So you could do so much. You can do so much with the Pythagorean theorem. All right, last one we're going to talk about. Oh, that looks good. That looks fun. I'm so bummed out you guys aren't here doing all this with me. All right, it's number 27. But I do have a few lucky subjects in here doing this with me. All right, number 27. So much fun. And then if you were here tomorrow, I'm going to build some stuff with you. And I have It's so much fun. We're going to do the converse tomorrow. I'm so excited. All right, number 27. We have this. Go ahead and redraw it. Don't just sit there and watch me redraw it. Because I know that's what some of you are doing. All right, this goes back, so here's 27. This goes back to the very beginning of this chapter that we're working on, where we had our little purple triangles that are here. Don't know who's there on the floor. We had these little purple triangles, and we took our shape. Let's find. We took this shape here, and we drew in the altitude, and then we cut it off. And what we said was we have this big triangle that looks like this. We cut the altitude. What are you doing back there? We cut the altitude, and we cut our big triangle into two small triangles. And we said what we have here are now three similar triangles. We have this big triangle, and then we have these two triangles, and we lined up the corners, the angles. And we said here's our 90-degree angle here, here's our 60, and here's our 30-degree angle here. So this goes back to that. I have my altitude that has bisected this side into a right angle. Therefore, I know it's the altitude, it's telling me the height. I can now assume, using what I know about similar triangles, that this big triangle is similar to these two small triangles, therefore making it a right triangle. So I know, seriously, watch the board. I know that this is a right angle here. Go back to those notes. It was section 8.1 we did at the beginning of last week. All right, so I know that this is a right triangle, so this is really not that bad. What are we trying to find? We're trying to find x. All right, so let's go ahead and find this whole side here. So I have 16 plus 15, so I've got 21. This is my hypotenuse here, so I should have 10 squared. Oh my gosh! Cardinal Matheson, right with the Pythagorean theorem first. I have 10 squared plus b squared, which is my x over here, is equal to 21 squared. 21 squared. I have to cheat for a second. 4, 4, 1. That's one that I don't really have committed to memory. 4, 4, 1. 10 squared plus b squared. All right, I have, sorry, this is 100. Subtract 100 from both sides, and I get 341. Is that going to work out? What do we do there? Huh? No, that's not going to work out. Maybe I can't assume that that's this triangle. That's not going to be my answer. All right, scratch that. Let's do another version of this one. Same thing. Maybe I can't assume. I thought that I could assume that that was a right triangle. All right, scratch that. Let's not assume that this is a right triangle. Let's go another way. All right, let's go ahead and solve for the altitude and then find my x, which is probably what some of you did, but I just got super excited there at the beginning. All right, so I'm going to have a squared plus b squared is equal to c squared. So a squared is 6 squared plus b squared is equal to 10 squared. I have 36 plus b squared is equal to 100. Subtract 36, subtract 36. B squared is going to be equal to 64. Divide both sides by 64. B is equal to 8. So here is that. This is probably even an easier way. to do this. Now, we're going to come up with another Pythagorean triple that isn't over here right now. Now we're going to solve for this hypotenuse. I have 8 squared plus 15 squared is equal to x squared. This is my Pythagorean theorem, so you know what I'm plugging into. I have 64 plus 225 is equal to x squared. What do we have? 9, 8, 2 is equal to x squared. Take the square root of both sides, and I should have x is equal to 17. So this is equal to 17. Yeah, and that's our answer. All right. What I want you to go ahead and do is the homework. So you're doing the odds on that page, right? No, the evens. I'm so sorry. The evens, 22, 24, 26, and 28. Now, here's your other problem. We would be doing this in class today, tomorrow, but you're going to do it at home. It's kind of can be your science experiment a little bit. You need to get a tissue box, okay? And there is this famous problem that says some guy was at the World Series, and one of the team members from the winning team gave him their bat. And he went through security, and security said, "There's no way you're carrying that bat onto the plane." And the guy said, "Oh my gosh, I don't have a box that's big enough." He tried to lay his bat down in his suitcase like this. He tried to lay it diagonally like this. It still isn't fitting. You can see, doesn't fit, doesn't fit. And so one of the TSA agents said to him, "Well, how about let's take everything out of your suitcase and we'll lay it this way. From this top corner, diagonally down to this inside bottom corner." So, how long is this distance in a tissue box? So we're going to reenact it with using a tissue box because I'm not going to go get a bat or bring a suitcase. So what I want you to do is go get a tissue box, and then you can get a string, a pipe cleaner, something, use your imagination. You need to measure the dimensions of your tissue box. And somehow, using the Pythagorean theorem, you might already see it by now, find the length from this top corner here to this inside bottom corner here. When you return to school, I expect you to bring a tissue box in, and you need to have somewhere on the box taped with a piece of paper, wherever, the calculations that you did and the length of the diagonal of this tissue box. So just so you know, have a great day.